In this video, we're going to talk about apparent magnitude and the apparent magnitude scale. So let's first start off with talking about apparent magnitude. Let's say that you are near your house, on the ground near your house. Here you are. And you are going to look at some stars in the sky. So you look at a red star, and you look at a blue star, and you see an orange star, and a faint greenish yellow star in the sky. Now they're all at various distances. This is what you see in the night sky. You don't know if the blue star is really near to you or the red star is really far away from you. All you know is you're looking in the nighttime sky. It's a very clear night outside, and there's no rain, there's no fog, it's very dark outside, and you can see all of these different color stars: the blue star, the green star, the red star, and the yellow star. And we want to rank these stars. So you decide that you're going to come up with a ranking system, and you're going to rank them based on their brightness and how bright they appear to you. So we're going to create a ranking system where you're going to label a 1 as a very bright object and a 6 as a very dim object. So let's go ahead and put that scale down. So let's go ahead and say that we want a 1 to be bright, and then we want a 6 to be dim. So that's going to be our scale here, bright to dim. So we have our 1, our 2, our 3, our 4, our 5, and our 6. So there's our 1, and there's our 6. And so this is going to be a magnitude scale, so we're going to give it a little m symbol, and it's going to be how bright the stars appear to your eye. So it's called an apparent magnitude scale. And since we're looking at our eyes, which our eyes see in the visible band, let's give it a little symbol, small v, to remind ourselves that we're looking in the visible band, or in the red, orange, yellow, green, blue, indigo, violet, the rainbow colors called the visual band. So you're looking with your eyes up at these stars, and it's dark outside, it's clear night outside, and we're going to assign these. So let's say you assign the blue star as a 1, and you assign the red star as a 6, and you assign the yellow star as a 4, and you assign the green star as a 5. So now you've got your ranking of stars. So this is how bright they appear to you, to your eyes, on a clear, dark night. Now somebody else may rank them differently, but if you have 100 people around the world, all on clear, dark nights, all looking at the same stars and coming up with their numbers, and you take averages, hopefully everyone will come up with the same ranking system, and we'll all put them into this scale called the apparent magnitude scale in the visual band. So let's summarize here. Apparent magnitude is how bright the stars appear to your eyes. And the apparent magnitude scale is a ranking scale that you've created from 1 to 6, with 1 being the brightest and 6 being the dimmest, and you're ranking the stars that you see on a clear, dark night based on their apparent brightness. So we call this the apparent magnitude scale. But what about other objects in the sky, such as maybe there was a full moon out tonight, or Uranus, or Neptune, or Venus? How do we put these objects in this scale? Well, we have to enlarge our scale, because these objects could be brighter or dimmer than our 1 to 6 magnitude scale. So let's go ahead and enlarge our scale. So here we have enlarged our scale from a -30 through 0 to +30. And you'll remember that the higher the number, the dimmer the object. So dim is going to be over here, and bright is going to be on the left side of the scale. So this is going to be the apparent magnitude scale in the visible band. So we're going to rank objects based on how bright they appear to our eyes in the visual band, which is what our eyes see, on a scale from -30 to +30. So the original scale way back in early times was from 1 to 6. And so let's put that in there. So 1 is right very near 0, and then 6 is right about here. So 6 is going to be our naked eye limit. So let's label that in there. So your eyes can't see objects dimmer than a value of +6. That's our naked eye limit. Let's put another one in here too. And let's put this value as 9. So 9 is right about there. So +9 is going to be the binocular limit. So if you had a decent pair of binoculars, you should be able to see stars with a ranking between +6 and +9 with your binoculars. So you can see objects with your eyes if they're in this region from -30 to +6. But if you need binoculars to see objects that are dimmer in the sky, you need to be in this range between +6 and +9. Well, what about over here between +9 and +30? Well, in this range, you need to have a telescope to see these ranking of brightness of objects. So let's put some famous objects on our scale. But first, let's clean up our scale. Let's look at some famous common objects, such as Vega. Vega is very close to 0. So let's put Vega in here around 0. Here's where Vega is. What about a planet such as Uranus? The maximum brightness of Uranus is around a +5, so let's add that in. What about Pluto? The maximum brightness of Pluto is around +14, so let's add that in. What about the maximum brightness of a moon of Pluto, such as Nix? Well, Nix, the maximum brightness of Nix is around +24, so let's add that in. Well, what about the Hubble Space Telescope? Since it mostly observes in the visible band, then what is the minimum, the dimmest objects that the Hubble Space Telescope can see? Well, that's typically somewhere around this +30. So this is going to be our limit for Hubble. So let's add Hubble in. What about negative numbers? So remember, the original scale was between 1 and 6. Well, the people that created the original scale forgot about other objects in our sky, such as Venus and the full moon. So Venus, at its maximum brightness, will have a value of about -5. So let's go ahead and add Venus in. What about the full moon? Well, the full moon, its maximum brightness is about a value of -13. So let's go ahead and add that in. Well, what about the sun? So the sun, as seen from Earth, is actually very bright in the sky. And so its value is actually around a -27. So let's add the sun in. So here we have the apparent magnitude scale, where we have ranked objects in the sky, such as moons and planets and stars, from -30 to +30. So if I were to ask you a question and said, let's take a look at Nix, a moon of Pluto, would you be able to see Nix with your naked eyes, or just your eyes? Can you go outside and look in the sky at any point on the clearest, darkest night and see Nix? Well, you can look at the scale right here and know your answer. And your answer is, that you should come up with, is no. You can't even see Nix with your naked eye, and you can't even see Nix with binoculars. You need a telescope to see Nix. But what if I asked the question about Vega? And I said, can you go outside on a clear, dark night, assuming the time was right to see the star, can you see the star Vega? And the answer is yes. You should be able to see Vega in the sky in the summer. The full moon, you should also be able to see with your naked eye. So this apparent magnitude scale ranks the objects in the sky, whether we see them in the day or at the night. We rank them on this scale from -30 to +30. And remember, plus numbers are faint objects and negative numbers are bright objects. Well, how can we say how bright one object is to another object? So let's go talk about magnitude differences and brightness. So let's talk about magnitude difference and brightness ratio. So the first thing we want to talk about is magnitude difference. So difference means the difference between two magnitudes. So let's say we have a magnitude of one object, and that magnitude is a 0, and a magnitude of another object, and that magnitude is +5. Then the magnitude difference is given the symbol delta, the magnitude difference is equal to m2 minus m1, which is equal to 5 minus 0, or 5. So that's the magnitude difference. Well, what about the brightness ratio? So let's erase all of that. And let's go look at the brightness ratio. Object 2 is +5, is Uranus. So let's return to our original picture. We were looking at, in a clear dark night, 4 different stars. We were looking at a blue star, an orangish yellow star, a red star, and a greenish yellow star. And we ranked them between 1 and 6. 1 being the brightest, which is our blue star, and 6 being our dimmest, which is our red star. So if I put them in there, our blue star was down here, and our red star was up here. Our orangish yellow star was about there. And our green star was right about there. Now these stars, when we looked at them in the sky, we know nothing about their distances. They could be very close objects or they could be very far objects. All we know is how bright they appear in the sky. And the way I drew it, the larger the star, the brighter the object. So I drew a big blue star, so that was our bright object, and I drew a smaller red star, so that was our dimmest object. So keep in mind that apparent magnitude and the apparent magnitude scale has no clue of how far the stars are. You could have a very big star, such as a red star, and it be very faint, and so we give it a number 6. You could have a very small star, but it's very, very bright, and it could be very far away. So we just give it a number 1. We rank it on how bright it is, not how big it is, not how far away it is. We only know about the apparent brightness. That's the only thing we know, and that's the only thing we rank.